Assalamu alaikum. My name is Junaid Hassan. My roll number is 55. Today I want to perform DSP Lab 8. No lab objective. Implementation and analysis of moving average filter. Implementation and analysis of finite demonstrate form. No task 1. We define filter for modify the character of digital signal. Second type of filter. We use low pass filter, high pass filter, band pass filter, band stop filter. All pass filter are used in lab 8. What, no, what are the time domain parameters for a filter? We use step response, overshoot, linear phase. No, what are the frequency domain parameters for a filter? Roll off, ripple in pass band, full stop band attenuation. Discuss the role of low pass filter for filter designing. We use select desired frequency while blocking higher frequency, preventing aliasing in digital signal processing. No, task 2. Plot the signal in time and frequency domain along with its magnitude response. No, define signal 1 to 40 is equal to 0. Now move toward the code. First of all, we define the signal, then plot the signal in time domain, then compute the Fourier transform of the signal, then compute the magnitude response, then plot the magnitude response in the frequency domain, then plot the signal in the frequency domain. No, this is output. Signal in time domain, magnitude response, signal in frequency domain. Now second signal. 41 to 120 is equal to 1. Again we use same previous code. We define the signal, plot the signal in the time domain, compute the Fourier transform of the signal, compute the magnitude response, plot the magnitude response in the frequency domain, plot the signal in the frequency domain. Again we use second signal, 121 to 161 is equal to 0. We define the signal, plot the signal in the time domain, compute the Fourier transform of the signal, compute the magnitude response, then plot the magnitude response in the frequency domain, then plot the signal in the frequency domain. So this is output. Signal in time domain, magnitude response, signal in frequency domain. Now another signal. 121 to 161 is equal to 0. Again we use same previous code also. Define the signal, add noise to X, plot the noisy signal in the time domain, compute the Fourier transform of the noisy signal, compute the magnitude response of the noisy, plot the magnitude response of the noisy signal in the frequency domain, and we use subplot command, plot the noisy signal in the frequency domain, and we use stem command to get output. Now this is output. Noisy signal in time domain, magnitude response of noisy signal in frequency domain. Now another signal. X underscore noise is equal to x plus 0.5 steric band size x. First of all, we define the signal, add noise to x, then define the moving average filter coefficient, then apply the moving average filter to x underscore noise, then plot the filter signal in the time domain, then compute the Fourier transform of the filter signal, then compute the magnitude response of the filter signal, then plot the magnitude response of the filter signal in the frequency domain. Then subplot command use then stem command to get output. This is output. Filter signal in time domain, then magnitude response of filter signal, and filter signal in frequency domain. Now another signal. Apply three taps symmetrically around moving average filter on signal x underscore noise and observe the time and frequency domain parameter. First of all, we define the signal, add noise to X, define the moving average filter coefficient, apply the moving average filter to X underscore noise, plot the filter signal in the time domain, then compute the Fourier transform of the filter signal, then compute the magnitude response of the filter signal, then plot the magnitude response of the filter signal in the frequency domain. Then we use upload command. Then we use stem command to get output. Filter signal in time domain. Then magnitude response of filter signal. Then filter signal frequency domain. Another signal. Apply a lemon tape symmetrically around moving average filter on signal x underscore noise and observe the time and frequency domain panel. Again, we define the signal and add noise to x, define the moving average filter coefficient, apply the moving average filter to x underscore noise, plot the filter signal in the time domain, compute the Fourier transform of the filter signal, compute the magnitude response of the filter signal, plot the magnitude response of the filter signal in the frequency domain. Then we use subplot command and stem command to get output. So this is output. Filter signal in the time domain, magnitude response to filter signal, then filter signal in frequency domain. Now again second signal. Apply 25 tab symmetrically around moving average filter in on signal x underscore noise and observe the time and frequency domain parameter. Again we define the signal and y to x, define the moving filter coefficient. Again we use same command to get output and then call the another function and compute the Fourier transform of the filter signal. Then we use subplot command and stem command to get output. Now this is the output. Filter signal in time domain, magnitude response to filter signal in frequency domain. Now task 3. Repeat signal 7.2 for 117 tab coefficient. Again we use same previous code for get output. We use constant and define the tab, then define cutoff frequency and then define shifting rate. Then calculate the normalized cutoff frequency between 0 to 1. Then calculate the filter coefficient using the Fourier transform method. Then display the filter coefficient. Then determine the transfer function using the filter coefficient. Then convert the transfer function to symbolic form of equation multiplication. And we use display command. We determine the difference equation using the filter coefficient, and then we use display command for difference equation, then compute and plot the magnitude frequency response, then plotting, then mark specific frequency. Now this is output, and this is magnitude frequency response. Now another signal. Repeat example 7.2 for 51 type coefficient. It is same like previous code. We define constant and define number of tab, define cutoff frequency and hazard. Again we use same command to get output. Now this is output and this is magnitude frequency response. Then another single repeat example 7.2 for 51 tab coefficient. Again we use constant number of tab, cutoff frequency and the sampling rate. Again we use same command and display the command signal you and then called stem command and we call the function and we use for now this is output, this is signal graph magnitude frequency response. Now part B, apply the filter made in part to the signal underscore x next signal g, observe the change for signal underscore x in time and frequency domain while varying the number of coefficient for the we use the region we define a regional signal generation. We define frequency, time domains, three signal and coordinate signal. Then plot original signal time domain, the plot original signal frequency domain, then